Today we are going to discuss the topic about torque speed characteristic of induction motor. First of all, torque equation of induction motor. The developed torque and induction torque is equation of machine is defined as the torque generated by the electric to mechanical power conversion. The torque also is known as electromagnetic torque. This torque developed by the different from actual torque available. So that the developed torque equation is mechanical power developed divided by mechanical angular velocity of the rotor is equal to PMD divided by omega r. Since PMD is equal to, we know that 1 minus S PG and omega r is equal to 1 minus S omega S. These two value is subject for the equation number 1. The above equations can be developed torque directly terms in the arc of PG and synchronous speed omega S. The omega S is a constant and PG is known as developed torque in bound directly. The arc of power PG is also called torque synchronous watts. The synchronous watts torque that develop the power 1 watt when machine is running synchronous speed. Output power P naught is equal to omega r T load. T load is equal to P naught divided by omega r. We know that P naught is equal to PMD minus P rotor divided by omega r. This is the fourth equation. Now the electrical power generated in the rotor given the equation shown in below. The electrical power is equal to 3E2S I2S cos pi 2S watts. So 3E2S into E2S divided by Z2S or 2 divided by Z2S is equal to 3E2 square E2 square, then Z2S. There are 2 is E2S and there are 2 Z2S. Z2 square, Z square 2S and E2 square. Okay. Then this is simplified to the 3 S2 S square E2 square RS divided by R2 R square 2 plus S X naught 2 O the whole square. This is the fifth equation. Then input power of rotor is given by the input power of rotor equal to 2 pi ns dt and S into rotor input equal to rotor copper loss. This value will be substituted on below the equation. Yes, rotor input is 2 pi ns dt. This value is substituted for this equation. Next, then rotor copper losses value will be okay. So 3 S square E square 2 naught R2 divided by R2 square S X2 naught the whole square. Then find out the value of TD. So TD is equal to 3 E2 naught square divided by this value is goes for the this opposite side, so that this value is multiplied and equal to other side, so division. So this value is division. So 2 pi ns into S R2 divided by R square 2 plus S square X square 2 naught. This is the equation number 6. Then TD equal to Ks E2 naught square R2 divided by R2 square plus, this is the equation of 7th equation. Now K is equal to 3 divided by 2 pi ns. So 2 pi ns value is omega s. So K is equal to 3 into omega s. It is a constant. Next, starting torque of induction motor. The starting torque of induction motor is TDST is equal to 3E square 2 naught R2 2 pi ns R2 square plus X2 naught square. This is the torque equation of standstill torque condition. Then torque speed characteristic of induction motor. The torque developed in the three-phase motor depends on the speed. The relationship between torque and speed can be represented the curve of shown in figure. which represent the first curve represent the speed torque characteristics. The starting torque is called log rotor torque while the maximum torque is called breakdown torque. Under full load condition, the motor runs at a speed of n. When the mechanical load increases, the speed of motor keeps decreasing until the torque becomes equal to load torque. When two torques are balanced, the motor runs at constant speed. But if the torque exceeds the maximum torque or breakdown torque, the motor stops abruptly. The speed of induction motor can be controlled by the adding resistance in the rotor circuit. The torque speed characteristic of induction motor are modified due to variation in the rotor resistance is shown in figure. This characteristic shows the speed of motor decreases with increases resistance value of rotor circuit. Thus, this method controls speed from rated speed to lower speed, and smoother speed control can achieved by increasing the external resistance in step. The torque of three-phase induction motor can be controlled by changing the stator reactance or rotor reactance or both. Stator reactance can be varied for both squirrel cage and wound rotor, but the rotor reactance can be varied only for a wound rotor motor by placing a external reactor in the rotor circuit. The torque speed characteristic of induction motor with changing equivalent reactance are shown in figure. These characteristics show that speed can be controlled from rated speed to lower speed in downward direction. The range of speed control in this method limited. The number of steps of external reactor determine the smoothness of speed control. Which step? Stepless and smooth reactance variation can be achieved by the using saturable reactor. Thank you.